So thank you very much. So I am a statistician, I'm not a surgeon, and I'm going to talk about tables and figures from the experience of the EJCTS. So I have no conflict of interest, but I am an assistant editor for the journals. So when it comes to summarizing data, we can look at three different types, broadly speaking. If we have a very small number of figures, then it's often suitable to just put them in line in the text, for example, the in-hospital mortality. If we've got a lot of unrelated statistics, for example, your patient characteristics data, then we would typically put that in a table. And if you have a lot of related statistics, so for example, biomarker values over time, then the optimal format for that would be a figure. So in some cases, figures are the natural presentation choice. So here we've got flowcharts and we've got forest plots. We would never really think about putting those in anything else other than a figure. Same applies for tables. In some cases, it is the natural choice. So for example, if we've got lots of patient characteristic data, different types of data unrelated, we want to make statistical comparisons, we want to add other types of comparison statistics, then a table is the natural choice. And if we want to summarize a complex regression model, but we want the readers to have the exact model coefficients, so I'm thinking along the lines of Euroscore or Euroscore 2, then we would publish again that type of information in a table. And then we come to the cases where it's a bit ambiguous about where we might go, tables or figures. So here's an example. In the EJCTS, we ask anyone who's doing a propensity score matching to report the standardized bias statistic for every variable in the propensity score model. And how might we then present that data? Well, we may present it in a table. So we just augment our table 1 with the patient characteristics. We just add 2 new columns in for the standardized bias statistic, or we may use a dot plot graph. I have no preference on choice here, so in this case it is ambiguous. One of the things we see a lot in the European Journal is just summary statistics reported, so often correlation statistics, Pearson correlation, and we just get reported, the correlation was 0.5. Now, in those cases, I tend to always request to see the data. So I would like to see some plots, and this is the reason why. So here we have some data. If I click play, then all these different data configurations have the exact same mean for both the x and the y-axis. They have the exact same standard deviations, and they have the exact same correlation statistic. So just reporting a correlation statistic, I don't really know whether it's a vague straight line or whether you've just drawn a dinosaur, but this is why we tend to always request that type of information. So Nature, recently this year, they've taken a stand on the publication of data distributions, and what they've said is they no longer want to see bar charts anymore, and instead they want you to use approaches that show the full data distribution, and this is something we encourage in the European Journal. So what does that look like? Well, this is the type of plot we might often see. It's called a dynamite plot. So here we've got some different treatment groups, and then the mean biomarker values are shown as the height of the bars. And then these plunges, or these error bars, well, they are showing +1 standard deviation. But these type of graphs don't show a lot of information. They don't show us the data. They don't tell us whether the distribution was asymmetric. It doesn't tell us whether it was multimodality. And we don't even see the lower error bar. So what's an annoying point about dynamite plots in particular, and why a lot of statisticians really dislike them, is when they're presented, here it's +1 standard deviation. Sometimes people present them with +1 standard error of the mean. Sometimes people publish them with the upper 95% confidence interval limits, and they just don't tell us what they are displaying. And so that adds further confusion. So what might we do? Well, we might plot an error bar plot, but really, in this case, it still has a lot of the same limitations as a dynamite plot, so it's not much help. So my general recommendation to people in the European Journal to date has been to use box plots. They provide us with a lot of information about the distribution. They show us the median, the lower and upper quartiles. They show us outliers, ranges within a certain range of the interquartile range. And so they're very handy. We can see the trends in the data from that, and we can get a good idea what's happening. If you have a small amount of data, then you may use a dot plot. So in this case, I've just plotted the raw data, but now we've gone to the opposite extreme because we can't see the actual summary statistics. So plots that have recently been used to overcome this, the so-called violin plots. So in this case, we're just showing density distributions of the data. So we are showing the full data distribution, but they're slightly unfamiliar to biomedical researchers, and this symmetry in those density plots is quite arbitrary. But of course, we may take one plot and another and combine them. So in this case, I've taken the violin plot and I've overlaid the raw data. So again, if you have a small amount of data, that might be a good idea. And one of my preferences of most recently is the ridgeline plot. So in this case, we're just showing a lot of density distributions, but because of the way they are aligned, we are clearly seeing the shape of the full distribution for each treatment group. Labeled the axes wrong, I think. So they're very informative and they're very helpful, and they would satisfy the nature requirements. So I just want to talk about what I call the anatomy of an informative figure, and I like to use the Kaplan-Meier figure to explain this, and the reason being it's one of the most common plots submitted to the European Journal or the ICVTS. And the one on the left is the figure we hope not to see, because then we have to type up a lot of comments to the authors, and the one on the right is the version we would very much like to see. So what's bad with the one on the left? Well, it has... This has been discussed earlier today, but it has poor font size. It's got unlabeled axes. The survival axis goes up to 120%, which is inappropriate. We've got undefined statistics, inappropriate breaks on the x-axis. So it's not very helpful, and we would have to write quite a bit about that. So the one on the right, well, now it's got the supporting data, in this case the tick marks. It's got the major grid lines, which helps us read off values. It's got the necessary supporting information that we request, which is the number of patients at risk for some discrete time points. It's got a nice legend, and it just looks professional. The axes are clearly labeled, etc. The same type of approach applies to tables. This is just a fictitious table that might be submitted to the European Journal, and this type of table would attract a large number of comments from a statistical reviewer. So just to name a few, we've got missing statistics. So in this case, if you're going to report a mean, we want the standard deviation. It's got inappropriate precisions. It's got inconsistent precisions. A very common error is that the percentages have been done by a calculator and they've been erroneously calculated. We've got undefined variables such as abnormal CRP. What does abnormal mean? We're missing units. So age has got years, but creatinine, I don't know what that's measured in. All values don't add up. So we do go through the tables in a lot of detail, or at least I do, and these are some of the points I would highlight from that. So I just want to sort of end with a few things of what probably you would like to avoid if you wish to inform rather than confuse, and this is mainly with regards to figures. The first one is 3D bar charts. Absolutely never submit 3D bar charts. That third dimension adds no information usually, or if they do, they're very difficult for comparison. This is very hard to read. This one from the New England Journal, you often can't actually read off the values, so they're just generally not useful. Graphs where you've only got a small number of statistics, we tend not to need them. They are a waste of valuable page space for the journal. So in this case, I've just got 3 percentages that all sum to 100%, 20, 50, 30. I could easily write that in line, in text, in a single sentence, and so I don't need the actual figure. Pie charts are a common statistical graph, but in fact they have a number of limitations. They can only be used for a very small number of groups. They're very difficult for comparison, and they don't display trends or patterns. And you can see about the comparison here, those 3 pie charts look very similar, but they are showing very different trends. If you're ever thinking about truncating a y-axis, which a lot of people do so they can zoom in on a part of data, think very carefully about this. In this graph here, it says, is truncating the y-axis misleading? It looks about 50-50, but if you read where the y-axis starts, which is 98%, then it's clearly a different message. Dual y-axis graphs, these are really difficult to read. They're difficult even if you can spend 10 minutes reading them, and a lot of people won't give 10 minutes to reading a single graph. So I tend to avoid these, and they're often poorly labeled. In this case, in this graph, it's very difficult to understand which axis corresponds to which. And then perhaps controversially, if you are considering reporting the area under an ROC curve, then we tend to see these ROC curves actually displayed as figures, but they actually add no extra value other than that statistic that you've already reported. So if I tell you that the area under this curve is 0.8, then you don't actually need to see this graph. It tells you nothing unless you're going to superimpose some thresholds along that curve. This adds zero extra value, and it will just waste half a page of journal space. So if you're interested in getting specific advice about figures and tables in the European Journal, where can you turn? Well, we have the journal guidelines, the statistical and data reporting guidelines, which are freely available on both journal websites. And if you go to the instructions for authors page, there is detailed instructions about how to construct a figure so that it's optimally presented for the journal. And so just to conclude, if you are going to submit tables and figures, then ideally they should only be used if required. Some people like to add figures just so they can add figures for the sake of it, but only if it adds some value to your paper. Those figures should be self-contained in the sense that a lot of people will flick through a paper and go straight to the figure first and try to see what information they can get from that. They should obviously be easy to interpret, so try not to add too much into your figure. Complex figures may look nice initially, but they're actually quite difficult to read. And then, of course, about the presentation, they should all be clearly labeled with legends, titles, etc., and neatly presented, so high quality resolution, font sizes chosen correctly, colors. And what I would advocate is that people use figure legends more. You can use a figure legend to add some more supporting information to your figure and how to interpret it, and that's a useful it's a useful tool, and then you don't have to add it necessarily into the main text of the article as well, so you keep the flow quite nice. And then I just want to end by, as a statistical reviewer, I always look at the tables and the figures equally as much as I do the main text in the statistical methods section. So it's very important that you put as much effort into those two things as you do the main study and the main write-up of the manuscripts. Thank you very much.